Okay, let's talk about drawing forms. The first one we're going to start with is a sphere because it's the easiest one. A sphere just starts with a circle. My movements for this are coming from the shoulder, by the way. That gives you a much smoother circle. If I tried to do this same circle like this, it's going to be oblong and kind of awkward feeling. If I learn to swing from the shoulder, come at it in a few passes, it's going to be a lot smoother. So right now this is just a circle, and honestly, without light and shadow, it kind of stays a circle. But you can hint at the sphere by just adding some lines that cross that sphere. And this is how I'm going to do that. I'm going to add halfway lines on the sphere, but I'm going to do it by drawing an ellipse from edge to edge in that sphere. That becomes my first half of the sphere here. And then in order to get another ellipse, all I have to do is draw it 90 degrees to the first is a good operating rule. So this one's oriented like this one's oriented like that. And I can decide on this intersection or this intersection, which one am I cutting here? If I want this sphere to be oriented kind of upwards like that, I'd firm this line up. If I want it to be oriented downwards like this, I'd firm this line up. Let's go downwards with it. Now we have a sphere, and I just firmed up one side of that ellipse, and it was enough to give me some clarity here. I have a sphere that's pointing more or less down like that. And that's it for drawing a sphere. They're pretty straightforward. The next form we're going to draw is a cube. These ones are a little more difficult, but there are things I want you to ask yourself when drawing a cube. The first thing to ask myself is, where is the front corner of the cube? For the purposes of the drawing that we're going to do, I'm going to have us lay out the cube like this. We're going to find our front corner. Where's the back corner? And where's the other back corner? These are the corners of the box. And right now you don't know, it's not even a cube yet. I have yet to decide, am I above the cube? Am I below the cube? What's happening? So let's say for this cube, I am above it. That means I'm going to be able to see the top here, which means my lines are going to go like this, like that. This line is going to recede back like this line, and this line is going to recede back like this line. That gives me a box that I can see the top of. That's not my only option though. I'm going to do some small ones off to the side here. All right, let's say we're seeing one from below. As you might guess, we're not going to be able to see into the top of this one. So there's one from below. And let's say, so here my eye level is up above. Here my eye level is down below. Let's say this is right at my eye level. Right at my eye level somewhere in the middle of this box. I can't see the top and I can't see the bottom either. This one I can see the top, so I must be above it. This one I can see the bottom, so I must be below it. And that's how to draw a basic cube. There are rules of perspective that you can really dig into with this, but for figure drawing, we're not going to dig into those really deeply. This is sufficient. Sometimes, here's another option. Sometimes you're looking at it straight on and you don't see either side, but you do see a little bit of top. We're up above it here, but it's facing directly at us. And you can do the same thing below as well. So there are endless amounts of practice you can do with these boxes, and I would get, if you really want to help your drawing, and I know it sounds really basic and simple, practice drawing boxes. If you can draw a box and envision it in all sorts of different orientations and situations, if you can think about the box holding the thing you're trying to draw, you can draw it in so many orientations. And that's it for cubes, or boxes. I'm going to call them boxes because they're not perfect cubes. Okay, and the last one is cylinders. And this is how I would go about drawing a cylinder. The very first thing I would do is find the orientation of the cylinder. Is it coming towards me, going away from me? Is it standing up straight? Is it laying on its side? Is it leaned halfway? What's the orientation of the overall cylinder? And I would get that first. So let's just arbitrarily say it's this. My cylinder is leaning just a little bit. And if we remember from the elliptical masses drawing, if you take a circle and tilt it, you get this ellipse. We need to imagine a little bit what the ends of our cylinder are doing. Let's say this one is just kind of a neutral cylinder. I'm going to try and draw an ellipse that's halfway across that line. I've got the same amount of ellipse on either side. Doesn't have to be perfect for this, but the more you practice that, the better it's going to get. And then I'm going to draw the other end the same way. Now all I have to do is connect the sides and I have my cylinder. But I'm not done yet with this. And in fact, I'm going to draw a couple more just to show you the difference. So let's say these are three of the same cylinder. I know one's wider and the others are a little bit thinner, but as far as how we're seeing these, they're roughly the same thing 3 times in a row. You have all the power to tell us as the viewer how we are seeing these cylinders. And let me show you how you do that. Here on my first cylinder, I'm going to ask myself, where am I in relation to this cylinder? Am I down below it, looking up? Am I up above it, looking down? Am I somewhere in the middle, right, looking at it straight on? Let's say for this cylinder, I'm up above it. So that puts my eye level up there. That means I will be able to see the top of this cylinder. Like if you imagine a soup can, if you tilt it so that you're above it, you can see the top of it. That means this ellipse is going to be open. And if this ellipse is open, so if I can see the top of it, I cannot see the bottom of it. I encourage you to try to get a soup can and look at the top and the bottom at the same time without bending the can. You can't do it. Then I'm going to connect the sides. There I am. And if this had a label on it, maybe it would go like this. Okay, what if my eyes were down here? Oh, you might be a step ahead of me. Then I would be able to see the bottom. I would not be able to see the top. So we're open on the bottom here and closed on the top. And if this had a label, you can see this label is arcing to reinforce what the edges are telling me. So there's a can that's above me or tilted away from me, either way, and I can see the bottom of it. The other option is my eyes are somewhere in the middle here, which means if my eyes are in the middle, I can't see the top, so that's closed. I can't see the bottom either, so that's closed. And there are my edges. If this had a label, it might look something like that. Those are your 3 options with cylinders. Here is something that can't happen with cylinders, and then some rules to remember about cylinders. So what can't happen? I can see the top, and I can see the bottom. And then what would the label be doing? Going like this? This cylinder can't happen. This one doesn't look like it's in 3-dimensional space. It's fighting against itself the whole time. So this cylinder is impossible, where you're telling us that you can see the top and the bottom at the same time. We can't do it. Here's another cylinder that I will see that also can't happen. We'll just share the same line here. Here's a cylinder that can't happen. Oh, I got to close the top and close the bottom. All right, what would the label here be doing? This again? This doesn't work either. It's not a cylinder anymore. It's like a sheet of paper that's bent towards us, which actually it looks like a little cubicle I could walk into, put a little person in there. This cylinder doesn't work either. These are no-no cylinders. So don't let me see these in the drawing where you can see both ends of the cylinder. That's no good. Or where you've closed it inwards. That's no good. Let's look at a few things about cylinders to remember and then we'll be finished. One thing about cylinders to remember is once you've found your axis for that cylinder, your ellipse ends need to be drawn 90 degrees to that. And by that I mean the long part of the ellipse needs to be oriented 90 degrees like that. Same over here. That's going to make sense. If I tilt this, like let's say I have that cylinder, the problem with this is not that it's not possible. It is. You could even have that where you see the top of this one and the bottom. The problem is this loses its descriptive power for describing a mass of the body. Mathematically, technically, it's possible, but for these drawings, don't let these ellipses get away from each other like that. They always need to be parallel. The ellipses on the ends of your cylinders should always be parallel. Another thing about cylinders is, let's say one's coming straight at me. In fact, we'll do 2 here. All right, so here is a cylinder that's not coming straight at me. See how narrow this end is? So there's a regular cylinder. But if I want this to look like it's coming towards me, I have to think about what happens when I turn something towards myself. Here's a thing of powdered charcoal. That's about the cylinder that I've drawn. If I turn this towards me, see how the end of this starts to get more and more circular until it's perfectly coming towards me in a perfect circle. That means if I want the cylinder to look like it's coming towards me, the end needs to be much more circular. Not only that, it might taper a tad as it goes back, and this ellipse is going to move towards this ellipse. The ellipses are going to get closer together. Because again, if you look at the bottom of this and the top of this, when I turn it towards me here, the bottom and top are perfectly overlapped. So I might have two overlapping ends like that. Sometimes you can just overlap them like that, just two almost circles overlapping. Connect the top, connect the bottom, and you've got a cylinder. Okay, and that will do it for cylinders for us.